Okay, so we're not actually going to find turning points today. However, we want to know some things about them. And a local maximum is the mountaintop here, and a local minimum is the valley. And it's local because you can see it goes higher over here, so it's not the ultimate mountaintop, it's going up higher. But as far as the things that are around it, everything around here looks like a mountaintop there. If you're in a mountain ski resort, and you assume, you say, oh, look at the mountaintop. And some people say, well, there's some mountains that are taller. Well, yeah, but it's still a mountaintop. Okay. And if you're in a valley, just because you're not in Death Valley or something, doesn't mean you're not in a valley. So anyway, the local just means, okay, it's not the absolute minimum. Obviously, there are things that are smaller. But, around here, in these parts, in this locality, this is the local minimum. Okay, so we're kind of curious about that. And this is interesting. The graph of every polynomial function of degree n has at most n minus 1. So what does that mean? Well, if I have x to the 7th, that means I might have 6 at most. I might have 6 turning points. We know that all of our, we're supposed to have 7 zeros, right? A lot of times we don't end up with 7 real zeros, and a lot of times we don't end up with n minus 1, 7 minus 1, 6 turning points. But it's possible. And but here's the thing. Here's the second part. If your polynomial function of n has distinct real zeros, okay, if let's say they all are, then that's how many turning points you do have. But let's say we had this 7, and you're like, well, the 7 gave us 5 real zeros. Okay, then you have 4 turning points, okay? It has exactly that many, okay? Points. Okay, so that's the thing. As many distinct real zeros, okay, so I know that we count like 4, 4, 4. If it happens 4 times, we count it. But if this is all we have, that's really just 1, right? And then we'd have no turning points. Okay, well, anyway, so distinct, that's important. Distinct, don't miss that. So that's an interesting thing, and we keep narrowing it down. I know we have calculators, and the next one is about a calculator. You can use a graphing calculator to find out what the maximums and the minimums are. And the maximum, like right there, where's my pen? The maximum, like right there, that's a turning point, right? And they're going to talk about the minimum too. That's another turning point. And your calculator can help you find these things. And I put this little thing up. You can take a look at this. If you have a TI-84 or a TI-83, basically the same thing. Right now, Texas Instruments will let you download software that will simulate a TI-84 on your computer, and that might be interesting. Of course, Desmos.com works really well as well. Right now, as I said, we're not actually going to do that. We're just going to estimate the coordinates of each turning point. So we're just going to look and see. So I'm going to say here is a turning point. It's a maximum. And it appears to happen at negative 1/2. Okay. We'll say relative max. We ought to label what we're talking about here. Relative max at negative 1/2 and, I guess that's 2 1/3. Negative 2 1/3. I don't know. We're just estimating here. Negative 2 1/3. There's my point. And, here's another one. Maybe I'll change colors. Here's another turning point. Looks like it happens at 1 1/2. And it looks like it also comes down here at 1, 2, 3, 4, 5 1/2. 5 1/2. Maybe 5 2/3. Oh, wait, it's negative. It's negative 5 2/3. 5, bigger 5. And 2/3. We'll just say we're estimating. We don't know. So we estimate the coordinates of each turning point and state whether it corresponds. Oh yeah. this is a relative minimum, relative min. Then estimate all real zeros. All right, well, I can do that. I'd say the real zero looks to be right there. And I'd say the 0 is 2 2/3, maybe? X is equal to 2 2/3. The least degree the function can have. Okay, the least degree that, so this is a little tricky. Okay, so first of all, you're like, hey, it only crosses in one spot, so, you know, if it's that must be just X. It's one spot, so now hang on, it's not that. I've got how many turning points? 2. So I know I have to have at least X to the 3. Because if I have X to the 3, then you know the turning points is n minus 1, so that'd be 2, because 3 minus 1 is 2. I guess I should say it like that. Because okay, so if it's 3, then I'd have 2 turning points. All right. And also, by the way, you have to think about, what if the x-axis were down here, and I hit here, here, and here? Okay, so that's definitely, it could have been 3 points. It just wasn't because of where the graph was. So you know that it's at least third degree. Okay, so that's a lot of things to answer. We want to know relative max, we want to know relative minimum, we want to know 0, and we want to know degree. So that's 4 things you have to say. And so at least we're allowed to estimate, and we're just thinking through it. We're not actually finding the turning points. We will soon.